Hi, I'm Keith Coffey, Senior Applications Engineer for Silicon Labs in Austin, Texas. Silicon Labs is a leading provider of innovative analog-intensive mixed-signal products, including isolation products. These best-in-class isolation products are based on our patented CMOS-based capacitive technology and provide unbeatable performance and reliability advantages over optocouplers. Silicon Labs isolators are capable of higher speed, lower power operation, greater noise immunity, higher common mode transient immunity, and longer service life than optos. This video provides an overview of common mode transient immunity, CMTI for short, and details the dynamic CMTI performance of Silicon Labs digital isolators. In this video, I will show both the dynamic CMTI performance of the SI84XX and 86X digital isolators, as well as the SI87XX and 826X opto isolators and drivers, using a well-regarded, calibrated commercial CMTI tester. Let's get started. The recent announcements of our SI86XX digital isolators and 87XX optocoupler replacements has created quite a buzz in the marketplace, so much so that a leading supplier of optocouplers has tested our devices and claims that these devices have extraordinarily low CMTI performance, less than 5 kV per microsecond, when they compare them to their own optocouplers. To set the record straight, this video will disprove these claims. Common mode transients can result from a number of sources such as IGBT drive circuits, fast high voltage or high current switching loads, motor drive, and/or floating power supplies. These transients can couple through local parasitic paths and onto the isolator or circuit board across the isolation barrier, causing data errors that compromise system integrity. This loss of correct data transmission across the isolation barrier is generally due to an isolator's poor CMTI performance. Reducing or eliminating common mode transient data errors requires robust common mode transient immunity. CMTI is the ability of an isolator device to maintain data integrity during fast CMT events. Modern-day isolators readily achieve greater than 25 kV per microsecond, whereas legacy optos generally are limited to less than 15 kV per microsecond. At Silicon Labs, we test CMTI using a system that generates fast transients. This test consists of a high voltage surge generator that generates up to 1500 volt peak transients and a high voltage differential probe to divide down the high voltage transients so that we can display the results on an oscilloscope. We also use a custom-built CMTI device test board to bias and properly mount the DUT into a high-voltage surge generator as mentioned. The diagram here illustrates the static CMTI test where the input is tied either to logic 0 or logic 1 during the test. This tester can be programmed to generate precise common mode transient events by changing the slew rate of the transient supply. The surge generator can also be programmed from 1000 volts to 1500 volts peak, and the slew time can be varied from 25 nanoseconds to 600 nanoseconds. This corresponds to CMT events from 2.5 kV per microsecond up to 60 kV per microsecond. Note that kilovolts per microsecond is the most common unit used to describe an isolator's CMTI performance. As mentioned, this tester uses a specially designed small circuit board like this one to host the device under test. Here we see the isolation device directly soldered down across two separate voltage planes that meet the creepage and clearance requirements for the device under test. Notice how small and well designed this board is to minimize inductive effects. Moreover, note that the test board can be configured to perform both static and dynamic CMTI testing. The diagram here illustrates a board that is configured for dynamic CMTI testing where the input signal is a square wave. To save time, we have taken data and illustrate the performance of Silab's SI86XX isolators here. As can seen from the graphic on the left, the 86 demonstrated performance that passes greater than 40 kV per microsecond. To find the limit of the SI86XX's CMTI performance, we increased VCM to 1500 volts and started reducing the transient rise time. As illustrated in the graphic on the right, we noticed that CMT failure started to occur at about 43 kV per microsecond. This is far higher than the competitor's 5 kV per microsecond claim. Again, to save time, we have taken data and illustrate the performance of Scilab's SI8266X opto isodrivers and 87XX opto isolators here. As can be seen from the graphic, they demonstrate a performance that passes greater than 40 kV per microsecond. This is 8 times higher than the competitor's claim. Now, to find the limit of the SI8266X and 87XX's CMTI performance, we again increased the VCM to 1500 volts and started reducing the transient rise time. As illustrated in the graphic on the right, we noticed that CMT failures started to occur at about the same level as the SI86XX devices, around 43 kV per microsecond. In terms of CMTI performance, the poorest performing device in Scilab's portfolio was the SI84XX family. This family illustrated a performance of less than 5 kV per microsecond as claimed by the competitor. However, note that this family is no longer recommended for new designs and has been replaced by the drop-in and function-compatible upgrade SI86XX family that supports greater than 40 kV per microsecond CMTI performance as demonstrated earlier in this presentation. So, just as you've seen, the SI84XX demonstrated the performance as suggested by the competitor. However, those devices are no longer recommended for new designs. As shown here in the summary foil, the dynamic CMTI performance of our latest generation devices has significantly better CMTI at greater than 40 kV per microsecond as compared to the competitor's claims. Well, thanks for your time. I hope you've enjoyed this video. Please check out our other videos as shown here. Also, keep in mind we are your one-stop shop for industry-leading isolation products that are second to none. Be sure to visit our website to learn more about Silicon Labs isolation technology and isolation products. Thanks again for watching.